Welcome back. Welcome back. Today we get into, oh my goodness, chapter 4, part C. The chapter that just won't end. Two more sections.
Go from 4, 6 to 5.
True. Well, chapter 5, that's next. We're hitting that right after we finish. These two sections this week, very important. Test is when? Oh my, a week from tomorrow. You ready? Let's go.
Chapter 4, part X.
No, that was a famous movie called Back to School. Back to School, I think that's it. And he had to take his final exam in English, and he said, "I only have one question." And then he unrolls a scroll, and it's like in 27 parts. So good times. That could be you someday. All right. Anyway, you picked a good day to be here for sure. Okay. This will determine how well you did a week from tomorrow. Okay. What the heck? Could you guys get closer? Yeah, I'm gonna be tap dancing on top of this. Push them back. Put them on the blue marks. What the heck? Keep going. Push them all back. Everybody on blue mark? Come on, son.
I'm on the blue mark.
Blue mark. Okay. Whoa. And while we're stalling here, find your unit circle. Find your unit circle. Who's on?
Yeah, I'll talk that away.
I'll look. Is that it? Oh, there it is. Hard to do this. Okay, don't stare directly. You'll burn your retinas. Right. All right, unit circle. Don't need it. Actually, don't need it, but you will. You will want to. You're ready for next year then. They will want you to know that off the top of your head when you get to calculus. Okay, guys.
Throwing it away.
Oh. Hurts. All right, guys. So our mini unit 4C is all about inverse trig functions. Take that out your ear. It's insulting to the professor. One of these days. Okay. So guys, you've written this down. I hope. Let's get started. Okay. Now, I'm going to show you not one, but 3 ways to solve these problems. You choose your favorite. You don't have to write that down. But here's the deal. Okay, I'm going to give you a problem, and it could look like any of these 3. Good news for you, they all are the same exact question. Write these down. Yeah, these all are asking the same thing. Okay. Of these 3, probably know one of them. We'll talk. 4 left-handed. We got this. Ours. Oh my. I just worked here. You guys are still here and you quit it. Oh, yes.
Did you get the rocket ship? Did you get the Hershey kids that no sound with me?
Oh, help yourself. I hide stuff around the room. Candy and money.
You want money? Can I take that trophy?
So don't touch my trophy.
It's hiding under the ribbon though.
Oh, go ahead.
I actually fixed the trophy.
What's that? Oh, chainsaw accident. I'll heal. Thank you for your interest. All right. Now, which one should you, oh, you found some candy? You did. There's more.
Check under the bell. I already checked.
Yeah, check under the bell.
I already checked. I already checked. Not this guy.
You can check under the bell. Stop.
I already did.
I'm good.
Oh, boy. If there are bugs that big, we're in trouble.
They are.
That big?
Yeah, everything was great.
That was an 8.
I thought it was five.
No, try it again. It's an 8. It's a little big. for-
Yeah, isn't it?
All right, back to business. All right. Now that we've all had our little candies and whatnot. All right, look at this one. By itself here. Hang on, I gotta get this out. Where will that fit? There. This one right here. Yeah, maybe you forgot the name of the chapter already, but what do you see there that sticks out? Inverse. What do, I know it's been a month. What do we use inverse to find? So this chapter, almost all your answers are gonna be angles. Almost. Okay, so exactly, okay, but looking for angles, okay? So let's go back to these other two ways to write the same problem. What seems to be missing here? The angle. Again, okay. This says find angle. This clearly the only missing piece is the angle. And let me take you back to Pythagoras time. All right, that's how they used to say inverse. So if you see arc sine, that means inverse sine. Okay, so all three of these are the same exact problem. Okay, and you will see it in all forms. Let me fast forward to your homework assignment. Haven't had it in a month. Do you see what I see? Inverse, inverse. They just will write it different ways. So, where should we begin? I guess I said I was going to teach you 3 different ways to do the problem. You were going to pick the one you liked best. Okay. So, whoa. So here we go. First time, let's see. Don't want to show you the steps yet. Okay. Let's try it this way. We've done this problem before. We have. I called it given 2 sides. So who remembers where? Whoops, that's a T and a C. Where should I draw my 2 triangles for this problem? Where is sine positive?
First and second quadrant.
First and second quadrant. Okay. So step 1 is to draw the bow tie pieces here and here. Step 1 done. Hilarious. Mixed with the non-winners. All right, step 2. Which 2 sides did I give you? If I gave you sine, opposite and hypotenuse. Okay, so you're going to put a 1 on the opposite, 2 on the hypotenuse. Okay. And then you could do Pythagorean theorem, could, or you could remember your special right triangles. We're going to use them every day. Every day. You should know. Do you recognize this? Maybe we'd better write these down. Let me find them. Special right triangles. Yeah, I think this will be beneficial here. There they are. Okay. You are so smart. Yeah. Recommend, you don't have to, especially if you got these on the brain already, like this guy. Okay. But you need to know the two special right triangles, or at least by sight. I'll probably give them to you, like on a formula sheet. But when you saw 1 and 2, you should have been thinking, oh, that's one of those special right triangles. And what's the third side? You already told me. Square root of 3. Okay. Copy those down. Now, also, all right, what do I call this? Hippies in the basement. Never heard me say that? I don't think you haven't lived. Okay. Who were the hippies? Is anyone passing history? 60s, but there were radicals, and you know, they didn't like the war and this, that, and the other, and the government, you know. So the government didn't want them down in the basic denominator. So what did they do about it? They multiplied by what magic number? 1. Because that's the only number you're ever allowed to multiply by whenever you want. So when they multiplied by 1, suddenly the hippies were up in the kitchen, and I guess that was okay. But there were no more radicals in the basement there. Okay. So just realize that if I give you this, all right, the book could be giving you this. They're the same thing. Okay. Same thing here. If I give you this, you could have rationalized it and gotten this. So have these 3 somewhere in your notes. You'll see them again. You will. Okay. And the 2 special right triangles. Right. All right, back to business. Okay. All right, so now to our problem that could be done 3 different ways. And there it is. Okay. All right, so help me here. You already told me this bottom piece is what? Square root of 3. What's this piece? Sink or swim? On the bottom of the lake. What is it? Okay. No negative, you're cooked. And on the bottom of the lake. Okay, sink or swim. Okay, you gotta have that negative. Got to. Okay. All right, step 3. Oh, actually, step 3 was you figuring out that this was a 30, 60, 90 triangle. Yeah. But the last step, okay, we need to find the angles that led to these 2 triangles. Okay, 30 is across 1. All right, what is this first answer right here? Of course, 30 degrees. And what's this one right there? 101. We'll go with this. 150. Those are your 2 answers to this problem. Okay. Now, me, I like degrees. I like angles and degrees. Math wants them in radians. Okay. Oh, but good thing I had you memorize 3 of them. 30 was pi over 6. Okay, so watch. 30 was 5 over 6. And how many 30s are there right there? That's 5 of them. So it's 5 pies over 6. So hear me now. Okay, on your test, I'm gonna be looking, when is it? Week from tomorrow? Okay, I'm gonna be looking for all 4 of those answers. The 2 in degrees and 2 in radians. Next year, they don't even want to see the degrees. They just want exact radians.
When you put degrees or radians, you get half credit.
If you only did a half one. Okay. But anyway, that's the way you learned how to do it before today. Okay. Now, remember those correct answers, because we're going to redo this problem twice. We're going to get the same answers. Okay. Now, what if I go to the picture of this guy? Anyone remember what it looks like? Of course you do. That was 4B. Okay, but let's save time and effort and look at a little Desmos. Okay. All right, do you see what I see? Okay, here is y equals sine x. Okay, and what did it say? Sine equals what? Half. Anybody got a spot for a half? Isn't that? Let's push this with my finger. All right, here's half right there. Okay. Thought it would say. All right, where else is it half? Right there. Okay. So bad news for me. It's not cooperating. But there are your 2 answers. Okay. Where x where the sine graph equals a half. So one answer here, one answer there. Okay. Now, can you read them here? I can't. All right. But it's 30 and 150 again. Okay. So you could use picture. Bad news, I'm not letting you use Desmos on your test. So this way, it's nice to know, but you're not going to get to use this except on the final exam. Okay. And then there's the third and final way, and it's called the unit circle. So get that out, and let's look at this together. Boom. Okay. Do you remember these things here? Okay. Okay. If I give you this problem in a wheel, what letter sign? Whereas y equal to 1/2, I don't think you'll be surprised. It's at 30 and 150. So all you really have to do is look at your unit circle instead of drawing triangles. Okay, so when it says sine equals a half, sine is y. Where is y equal to 1/2? 150, 30, and the radian equivalents. Okay, so now that you've seen one done 3 different ways, I'll give you try. Write off your homework. Bang. Give me 2 answers. Should be already be done. Use your unit circle or draw me 2 triangles. Okay. But be smart about this, my high flying honors group. What do you see in this problem? A radical 3 and a 2. Goodness, could that be the 30, 60, 90 again?
Why are we 3 and 2 pi?
Waiting. How do we do this with this? Oh, unit circle is easy. But to do this by hand right before lunch, where is sine positive again? Here and here. Which 2 sides? Opposite and hypotenuse. What's the missing third side? Good. We're getting good at that. What's the reference angle across from root 3? Who's across from root 3? 60. And from here, my two answers are 60, or how much is that one? 120. Okay, so look, we know the two answers. But let's get good at converting them to radians without using a unit circle. This was pi over what? That's pi over 3. And how many 60s do you see there? So that's 2 of these. Okay. And like I say, for you guys, for me, I'm gonna let you use the unit circle on the test. But next year, they're gonna expect you to have it off copy. Okay, so that converting, you're ready now. Okay. Nope. Before we go to lunch, same answer off unit circle. Where is sine square root of 3 over 2? And it better be the same two answers, right? Yep. Okay, so sine is. So where is y positive? Root 3 over 2 up here and there. So the two answers were 60 and 120, or the radian equivalents. All right, good place to stop for now. Try not to forget it all on your way.
My best.
All right. Yes, sir. Hang on 1 second. Okay, guys, before we get back to what we were doing, let me introduce you to the trig inverse pictures. Think for a minute. Okay, you should remember this. Okay, from the unit we just finished, went up 1, down 1. And how long did it take to complete a full cycle for sine? 2 pi. Okay, you remember this much. Right? So there's the original graph. Okay. So what should the inverse look like? You remember that from units past, from years past? Something about a mirror image over this magical line called y equals x, right? Because how do you find inverses? You switch what? X and y. So I know when I taught geometry as youngsters, I was just like, switch the paper. Okay, make the x the y and y. Oh, there's the inverse. Okay. So similarly, all right. What's the domain here? 0 to 2 pi. And the range is 1 to -1. So what do you expect the inverse? Those need to do what? Flip-flop. So no use hiding the ball anymore. Here's inverse sine. No. Yeah. Copy this one down. That is what you're going to have to recognize. That's all I'm going to have you do with it for inverse sine. Remember, arc is the same thing as inverse. Now, what do you notice? Instead of going up 1, down 1, it went 1 which way? Left and right. So what used to be our up and down is now our sideways. And instead of going 0 to 2 pi horizontally, that's now vertical. Okay. And I'll explain in a minute why just that chunk. But let me let you copy these 3 pictures down. That's inverse sine. Here's inverse cosine. Okay. Similar. Just a chunk. You remember what tangent looked like? 2 asymptotes and 3 dots that made a, what did I call it? Incline. Yeah. Okay. So for tangent, the last one. Yeah, it's still got 2 asymptotes, but they're going sideways now instead of up and down. Okay. So these are the big 3. Might be others, I don't care. These are the three I want you to know by sight. That's it. So on the test, I'm gonna give you matching. I'll draw a bunch of pictures and you gotta tell me which one's sine, cosine, tangent. Okay. Easy. Easy. Articles, you could probably tell me, where do you think that is? Anybody? We're using pi as going up. Half pi, yeah, pi over two. You don't need that. Like I say, I just want you to know them by sight. Now, truth be told, I could pull this on you. You should be able to handle it. All right, let's see. You don't have to write this one down, but where to move?
Who's on the Y?
Left three, because it was in the parentheses. So for full credit, I would just expect this picture to be over three. If that makes sense, not drawing the scale. It's where would this be? Let's see. This one started at 1, so now it's -2. And this one, I think. So you could do all that shifting graph business that we did last year, but we already did that. So I'm gonna let you off the hook there. So you just have to know them by sight. Now, here's the why. Why was it just a little chunk? Okay, because what if I did this for the inverse? How come they only, yes, they went down here too. How come they only cared about this piece? Why did they chop off the rest? Because these are called inverse trig functions. What do you notice about this guy? It's not a function. Why? Vertical line test, right? So they're like, oh, gee, they're like, okay, well, let's pretend this wasn't even there. Okay, now it passes the vertical line test from here to here. Okay, so that's why. You're only going to have to worry about the chunks of sine and cosine. Okay. Put that on the back burner. Let's get back to what we were doing when you left. All right, let's get good at this right now. I have a Kahoot. We could do that. Well, you got to get good at it first. So. All right, how about this? All right. Got your unit circle handy? Try to get blurt out answers. You don't have to write any of these down. And it's too small for you to see it from the back, so you're looking at your sheet. Yeah. All right, we did 2 before lunch, so let's do another one. How about cosine inverse of 0? Name 2 places where that happens. Remember, we're looking for angles. Where is cosine equal to 0? Where does the x equal 0? I heard 90 and 270. So how would you write your answers? 90 over 270. I over 2 or 35. For the rest of today, let's just do degrees. But for the homework and test and all, give me both. All right. So cosine. Let's do this. Cosine inverse root 2 over regular 2. Here's cosine positive root 2 over regular 2. So again, what letter are we looking for? Cosine is x. Where is x equal to positive? There it is right there. So it's 45. Where else is cosine positive? Remember ASTC? Fourth quadrant. See it right there. 315. Now, that's how quickly you can do these. But when it comes to the test, I need to see where the answer came from. You've heard me say this before, right? So I would expect a little picture where you labeled the 2 points that gave you, oops, that's positive, the answer. Okay, so in your homework tonight, if you're doing them off the unit circle, draw where the answer came from. All right, let me spice it up for you. How about first tangent spicy. See if I can get it. Got it. All right. How about some helpful hints? It's radical 3 over what? 1. Okay. So if we weren't using unit circle, okay, where is tangent positive? Which 2 quadrants? 3 for sure. And where's everybody positive? Yeah, guys, it just told you your 2 answers are in those 2 quadrants. So now you're going to look for this in quadrant 1. You don't see it. Okay. You remember tangent was y over x. Okay. So here's the truth. The answer is right here. Right. And what if I do y over x? I get this. What do I cross out immediately? The 2's. So why don't you go to school on this? Okay. What you see in green C, okay, those are the tangents. All I did was put y over x and get rid of the 2's. So for 60 degrees, it's radical 3 over 1. Okay, so all you got to do is look for y over x, remembering that they always have 2's. Okay, so the answers were, let's say I did this with a triangle. I put O and H. What's the hypotenuse? 2. And most important, this unit, what's the reference angle across from root 3? Not 30, 60. And our 2 answers are 60. And how much is that one? Now you went past 180 to 40. Okay. So the answers were 60 and 240 radian equivalents. There they are, 60, 240 down here. At negative root 3 over negative 1, which you know is positive. Is that as spicy as it's going to get? pretty much. Yeah, if I can get the Kahoot working, we can do that. But instead, let me give you 3 U tries and then we'll move on. All right. These should take you no time at all. What? Okay, these are spicy. See if you can do them. Use the unit circle or draw yourself triangle if you prefer. Those 3. Right now. Is this you? I missed you guys. I want to mess with this in the house. That's what I was for. I'm actually.
Wait,
Waiting.
so for the, where is 3, 1, and 2 triangle for this thing, right?
Yes,
This square root of 3.
is always across from 6.
No, I was like, the if you do Pythagorean theorem to that, it'd be +1. And I was like, 3 + 1 doesn't equal 2, and I forgot. Wait, yeah.
Square root of 4 instead of just 1. You get it, yeah? That's the tough one. For everyone. So which one? Cosine is X. Doesn't say 1/2, it says 1/√2. Draw a triangle. You get it right. It's like we need the practice. All right, I'll take stunned. You're new to this. Okay, guys, work with me. All right, read that to me. We're looking for what? Where is sign positive or negative? Positive. Okay, I pulled this trick on you. That -1 means nothing. It just means go find me an angle. You want to know where is sign +1? Beware. Okay. So where is y equal to +1? One place only. Where is it? Y is 1 right there. Oh, so what angle is that? 90 or /2. Okay. Now, If the only mistake you made was looking there, that's easy to fix. That's X is. Yeah. But hearken to me, you're this -1 only means go find an egg. Doesn't mean negative. Okay. Second one. Can in, okay, we're looking for where can is what, positive or negative? Well, this one we got a negative. All right, so can is -1. In which two quadrants? Where's tan negative?
Three.
No, 3 is where it's positive. That's so we want quadrants 2 and 4. And we're looking for 1/1, better known as same X and same Y. And that's there at 135. And where's the other one? Okay. 3π/4 or what's that one? 7π/4. Okay. Now, some people drew a triangle there, maybe. Let's talk to them. Maybe not. Space. Thought that would work. Man, let's try this. That's better. Okay. So if you're doing this one with a triangle, you just told me to draw 2 triangles here and here. What are the 2 sides? Tangent is OA. Anyone recognize that special right triangle? First time appearing today. Square root of 2, but which one is this? Yeah, square root of 2 is nice, but the answer comes from you telling me this was the 45/45/90. And now there's 135, and what's this one? 315. Yeah. 3π/4 and 7π. So you could go a triangle on this, but what you really need to do is get better at finding tangents. Okay, and that's where I recommend you write down all these green things. Okay, what's y/x? 0/1 is 0. What's 1/√3? Boom. Convert it. What's radical 2/radical 2? 1. So you can do this yourself, but tangent's going to be the tough one. All right. Why is this a tough one? What letter are you looking for cosine? Okay. Did you know there's no x on the whole board there? That's 1/√2. Think back to like one of the first things I had you copy down. What's another name for 1/√2? Yeah. Okay. So to refresh your memory, since you had lunch, okay. Okay. I gave you this, but this is what it's going to look like on the unit circle. Okay. So you got to think, well, okay, now I'm looking for √2/regular 2. And where is that? $45. Oh, come on. √2/regular 2 is here and here. So the answers were π/4 and 7π. Okay. Had enough of those for now. You just gotta practice. All right, 2 more problems for notes, and then I'll give you the rest of your time. First notes in a month. And this year, that's right. Okay, last 2 are doubles. Those were singles. Yeah, write this one down. 2 words instead of 1. This will separate the A's from the correction pile. Let's go. A double. 2 words instead of 1. And where do you usually start when you have parentheses? Inside. That is absolutely correct. So step 1. Start on the inside like there was no outside. Okay. And this is straight up unit circle. Go to your unit circle, 90 degrees. On my test, you're going to draw me this picture and write that point, that 90 degrees. Now, what letters do we need for cosecant? We need 1 over y. What is cosecant on this red picture? What's 1 over y? 1 over 1 is 1. So you're going to change that to a 1. Right, so you just changed it from a double to a single. Okay. That's it. 2-step problem. Give me the answers for the one I circled. Where is cosine equal to positive 1? We'll draw a second picture. And where was, what letter cosine is? X. So where does X equal 1? You said 0. Okay. So here's what full credit looks like. You gave me the answer in both degrees and radians, and you showed me where you got both answers. Okay. So that's a double. Work your way inside out. No. Down 1 to go. Okay. So that one had the inverse on the outside. So the last one, we're going to switch it around and have the inverse on the inside. And here it is, finally, the only problems that won't have angle answers. Remember, we started by saying almost all your answers will be angles, not this one. You'll see why in a second. Okay. And there ain't no unit circle in the world that's going to save you on this problem. You got to be able to draw me a triangle. In fact, 2 triangles. We're going to do inside first. Okay. Pretend you remember unit 4A. Where do I draw 2 triangles for that? Secant, positive or negative? Positive. Good. You didn't fall for that -1, did you? So guys, where is secant positive? Secant, remember secant's buddy. Who's secant's buddy? Cosine. So where's cosine positive? Yeah. So if that's your thinking. Need to draw me 2 triangles, 1 and 4. Why? Because that's where cosine is positive. Okay. Step 1 done. Step 2. Can't do that yet. Where do I put the 13 and the 5 if it's secant? What 2 letters did I give you? No joke. Right? Sha, cho, sha, cow. All right, so make the hypotenuse 13. and the adjacent 5. Who remembers their triples, or at least has them in their notes?
8. Is it 8?
12, that's correct. Okay, so your last step after you put a 12 here and what here? Good. Okay, your last step is to go outside, pull cotan off of these two pictures. What's cotan here? That was cow, right? In the A over O, right? So what's adjacent over opposite on the top one? 5 over 12. And what's the cotan down there? 5 over negative 12. Okay. You can put the negative wherever you like. Okay, so take one last look. What kind of answers did you get? Not angles. This is the one problem where you're not going to get angles, and you had to draw a triangle. The unit circle doesn't have 5s and 12s and 13s on it. So that ASTC important, and your Chosha Cow. Yeah. So you've seen it all. You just need to practice and get good at it. That time has come. Welcome back.